Okay, what's going on, guys? In this video we'll reverse a stack using recursion. Okay, so the logic that I'll be going to use to solve this problem is almost similar to the logic I have explained in my previous video, reverse a string. Okay, so if you haven't watched it already, I would insist you to watch that first. Okay, so let us just first initialize our stack and then I'll explain you the logic what I'm going for. Okay, so I'll use a DQ. And let's just initialize at 1, 2, 3, 4, 5. Okay, and now I'll take a stack. Let's call this STK. I'll pass the DQ container that I've made in the constructor, and now what I want is I want to first print the stack, so that after reversing that stack we can we can see the difference, what difference is there. Okay, let me just clear this output. Okay, so what we want to print the stack, then we will reverse the stack and we'll print it again. Okay, so the logic behind this problem is that the logic behind this solution is that what I'll do is, all these elements are there together in this container stack STK. Okay, but what I want to do is I want to separate these individual element and store it in a separate variable. Okay, and this variable will be unique in every stack frame. Okay, so for the first recursive call I want to store this element 1. Okay, I want to store this element 1 and remove it from the original container. Okay, now in the second recursive call, our container will contain only these elements. Okay, now I will pop this 2. Okay, and then I'll pass this rest of the stack in the third recursive call, and third recursive call will contain this container, and the same process will repeat. Okay, so let's start writing the reverse function. Okay, so this is our reverse function. It will take a stack as a parameter. Let's call this STK. Okay, now as I said, I want to separate each of these elements, right? So let's create a local variable and let's call this last value. Okay, and this last value should be the topmost element of that stack, right? So this is the topmost element of our stack, and the next thing look at it carefully. We have just copied this element, we haven't removed it. Okay, so what we want to do is we now want to remove it. So I want to pop it, and now it's removed, and I have stored the copy of that variable in this last value, copy of that number in this variable last value. Okay, now I will keep on doing this recursively. Okay, so reverse, and I will pass rest of this stack. Okay, so now after popping, the stack that is being passed will contain these elements, that is 2, 3, 4, 5. Okay, now think of it, I will keep popping it till when? Okay, so until I want to keep it popping until the stack goes empty. Oops. Okay, and if it is empty, obviously we'll return it. Okay, now as we know, okay, now so I hope you are clear till now that we have all we have done is that we have removed each element from the container, that is this SDK stack, and we have keep these we have kept these copies of each element in this variable last value, and this variable is unique at every recursive call at every stack frame, because at every stack frame the new copy of that the local variables and the parameters are created. Okay, so new. After that, what I want to do is I want to just insert it. Okay, now this is no normal insertion. Okay, because if this element was not there, okay, what we'll receive is the original stack back. Okay, and we don't want that. We want the stack to be reversed. Okay, so if this is 1 2 3 4 5, the stack which we want after this after calling this reverse function is 5 4 3 2 1, right? Okay, and because I have used DQ to implement this, the actual values, the order of the values in this stack would be 5 4 3 2 1, and after reverse it will be 1 2 3 4 5. It will be clear after I run my program. Okay, so let's call the insert function. Now just one small thing that you have to think of. Think about the last recursive call. Okay, so what element will be there at the last recursive call? That's right, the last element will be 5, right? Last element will be 5, and now the stack will be empty. Okay, so what we want to do is simply insert that 5 into the empty element. Okay, so I'll pass the empty stack and the last value. Okay, and this, now just write the insert function. It will take a stack, and it will take 1 into last value. Okay, now if our stack is empty, okay, if our stack is empty, we'll just simply push back. If our stack is empty, name of a stack is SDK. So if SDK is empty, we'll just simply push that element, which is the last element, in the stack container. Okay, so stack push the last value. Okay, and we'll just simply return it. But what if our stack is no longer empty? Okay, so what we have to do is, just to reverse it, we have to pop all the elements. Okay, in this case we have to pop 5 and then push the element that is being passed. Okay, so what we'll do is we'll try to replicate the behavior somewhat similar to what we have seen over here. So what we can do is we'll create one more local variable, and let's call this popped element. Okay, and it will contain the topmost element, and we'll then pop it. Okay, and after popping, I want to call this insert function recursively. Okay, because what if there are more than one element? Okay, and more than one element, and we want to insert the last value in the last. Okay, so just think about the case of inserting 1. Okay, when one is being inserted in the last position, there are 4 more elements in front of it. So what we have to do is we have to push 5, then 4, then 3, then 2, and now our stack is empty. So and here's the condition that we have written for it. So we'll just push 1, and then let me just call it recursively insert and we want to insert the last value. And now what we want to do is, after 1 is inserted in the last position, we have to push again all the popped element. Okay, so we will pop again, we will push again. So we'll say stack push. Okay, and what we'll push, we obviously yes push the popped element, and that's it, guys. That's the whole logic. And there's one small thing that I forgot. I should pass this by reference because I'm returning nothing, otherwise it will show some unexpected behavior. Okay, and now let's just quickly write the print function. Okay, while we have to print it, we have to keep printing it until our stack is empty. So while stack empty, while stack is not empty, okay, so while stack is not empty, we have to just print the topmost element of that stack. So stack dot top, and then we'll pop it. Okay, we'll remove that. So let's call this stk dot pop, right? So let's see, it should just work fine. Let us just do a quick recap of what we have done over here. Okay, the main logic, this reverse and insert. Okay, so what I'm trying to do is that these elements or these numbers are together in this container called stack stk. Okay, now what I want to do is, in order to reverse this, I want to fetch all these individual elements and store it in a local variable. Okay, and these local variables are unique because these local variables are created at every stack frame. Okay, so this I will keep on doing this until my stack is empty. Once my stack is empty and I have stored the individual numbers in this variable called in this variable called last value, now it is the right time to insert these elements at the right position. Okay, so now I will call this insert function, and I will pass my empty stack, okay, and this last value. So think of it, for the last recursive call, the value of the last value would be 5, okay, and the stack would be empty. So then we'll pass it, and because the string is because the stack is empty, we'll push this element. After that it will return, and the value of the last value variable will be 4. 4. Okay, and after passing this stack and the last value, we see that okay, stack is no longer empty. So what we will do is, we will pop the element, or we pop the number 5 and then call it recursively. So after calling it, it will find that okay, now the stack is empty. So okay, so this means that we can insert the last value, that is 4, in the at the last. Okay, so after this is done, it will return, and then we will push the popped element, and the value of the popped element was 5. So by going by this logic, now the content of our stack would be 4 and 5 and then 4. Okay, so let's run this, and I think it should work just fine. Let me see, there is no error. Okay, so let's run this. Okay, cool. So the output is correct, but I should just write one end line over here so that it is well formatted. Okay guys, I hope you can see that initially, and this what I was talking about, that although I have initialized my DQ in this order 1 2 3 4 5, but in stack it reverse. Okay, so after this this was our original stack, and after calling the reverse function, the order of our stack is reversed. Okay, and this was the whole problem statement. Okay, so I hope the logic behind it is clear. Okay, so that's all for this video, guys. I'll catch you guys in the next one. Bye.